Okay, so hi everybody, and in this video we will plot the decision tree. Okay, so this video is mainly based on the plotting mechanism, how we can plot a particular decision tree, and how we can plot or visualize a particular decision tree based on our data set. So this data set that we are going to use in our this exercise is basically a iris dataset. This is a standard and classical dataset that is used by many researchers for machine learning purposes, and this actually comes preloaded with the Scikit learn machine learning library. So we are going to use the pandas library. This pandas is actually a Python library that is being used here, and next we will use the numpy library, and after that we will use the scikit-learn and import the datasets. So from scikit-learn we are basically importing all the datasets that we can use in our work. So in this work we are going to load the iris dataset. So the command is very simple. It is a datasets dot load underscore iris. So this means that the dataset will be loaded, and the iris can be hold the iris dataset. So as you can see, I have opened up the scikit-learn toy dataset library, and these toy datasets all comes preloaded with the scikit-learn library. So the Boston datasets and the iris datasets, the diabetes, there is a digits for digit recognition, digit classification, and for there is a wine dataset, there is a breast cancer dataset, and all these datasets are coming loaded with the along with the scikit-learn. So coming to the iris dataset, this dataset is actually as I open the link, and as you can see, there are three classes. There is three different types of flowers that are classified here. So it is a multi-class classification problem, and the samples that there are totally 150 records, 150 rows, and for each class there is for each number of classes there is 50 records or 50 instances, and totally there are four dimensionals. So that means there are each flower is being separated using four uh, features. So the features are real and positive. So it is basically a set of numbers. So this is a set of dataset, and as you can see, as you scroll down this page, you can see that there is an example for loading the iris dataset, and we can just display the target names or the column names, or we can get the target values also. So similarly, I am just using the features name as a constant for storing all the column names. That is a sepal length, sepal width, petal length, and petal width. So all these are four dimensions. These are the four features that we will use our machine learning algorithm, or we will use our decision tree to learn. Okay, so we have data frame. The pd.data frame is as seen in our previous video about the decision tree. This data frame method from the pandas class actually creates a data frame. So the data frame is basically created using the iris.data. So this iris.data is the one variable which holds all the records of the iris dataset, and the columns is given as the array. So feature names is holding the columns, so the columns is equal to we are assigning the columns here. So coming to the iris.target, the target variable, that is the number of classes, or sorry, the type of class. There are three type of classes. So the three type of classes are stored in y. So we just print the x and print the y. So x holds all the features, and y holds all the three different classes. So 000 and 111 for to second class, and 222 for the third class. So such a way the machine learning dataset, the iris dataset is presented, and it is a standard dataset. So it is just only used for the demonstration purpose. So next we create the decision tree classifier. So in this model I just only create the decision tree classifier without specifying any criterion or any parameter. This is just a simple basic decision tree classifier without any parameter. So all the default parameters will be assigned here, and the model will be fitted with the features and the labels, class labels. So next we take the decision tree. So there is something called as export graph viz. So graphis is basically a function that generates the decision tree in an out file. So it basically renders an out file. So this out file is can be converted to a png file or a ps file based on the dot output that is presented in the graphis. So this export graphis is used to export the decision tree model into a dot file. So this is output tree dot file, and this is the model, that is the decision tree model that we have trained, and the feature names are given in here. So this way we are exporting the decision tree to a tree dot file, dot file. So this file can be used to visualize the decision tree. So in order to run the command, so this command is actually to be run on the command prompt. So because Google Colab can support running command prompts commands using the exclamation mark and followed by the commands. So this dot is a class. Okay, it is a file. So we just we target set the target to the png, so the output will be a png file, and we give the input as tree.dot, that is a file that is exported with the help of the export graphis method, and we set the output -o, that specifies the output. So we create the tree.png. So this tree.png will be created and stored in our file, that is the repository. Okay, so this files is it is actually created dynamically when we run this command, and these files will be stored in our Google Drive. And remember, this tree.png, this it is created when this particular command is executed. So the tree.dot file will be converted to a tree.png file, and we can just display the tree.png file using the OpenCV library. Okay, so we import the Matplotlib library here, and we import CV2. This CV2 is we are using that to OpenCV libraries to read the tree.png, that image file, and then we plot using the Matplotlib function as for the figure size 20 to 20 comma 20, and we just plot using the pld.imshow, that specifies that we show the image, and we give pass in the image file, that is the tree.png, and this is how a particular decision tree will be visualized in the Google Colab. And based on your research problem, you can visualize the decision tree, and how the Gini values are calculated, you can easily identify. So remember that the petal length is selected here, and if it is lesser than or equal to 2.45, if it is true, then the left subtree will be chosen, and if it is false, the right subtree will be selected. So the total number of samples is equal to 150, and the Guinea actually means that there are some impurities. So 0.667 means that there are impurities, and we have the values of 50, 50, 50. Yeah, okay. So if the petal length is lesser than or equal to 2.45, it means that Guinea values is 0, 0. So it means that there are no impurities. It means that all the records are of, say, the same class variables. So hence here the samples is 50 and the total value is 50, and when it is false, it means that the petal length can be further petal width can be the next attribute, that is the next feature can be used for further splitting up the values. So here note that the Guinea values has been reduced from 0.667 to 0.5. So it means that further it can be reduced, and similarly based on the petal width, there are two separations, and based on the petal length, there are further separations for petal width, and in ultimately for sepal length, after for sepal length, you can see that all the leaf nodes have the Guinea index as 0. So the Guinea error, the Guinea is the level of impurity in the decision tree. So remember that all the impurities are 0. So hence there are only these kinds of records, that is three classes. So first one is having 47, and next one is having 1, and next one is having 3, and next one is having 2, and next one is having 1, and next one is having 2, and next one is having 1. So similarly for where different classes, we have different leaf nodes, and these leaf nodes is actually split using this mechanism. So this following this way, you can easily visualize that particular decision tree that you have created, and you only need to make sure that this the decision tree visualization can only be done using the graphviz command. So graphviz command, we export the graphviz to a tree dot file, and then we converted it into tree.png, that is we converted the dot file to a png file, and after that we use the OpenCV library CV2 to read the image and then later on display it in the Google Colab. Okay, so I hope you enjoyed this video, and feel free to share any comments. And if you like this video, if you are enjoying the machine learning series, kindly share the video, like and subscribe, so that these videos can reach many other people. Okay, so thank you very much. I'll see you in the next video. Thank you so much.